Okay, so we are done with the AP part, arithmetic progression, and for today's class we have geometric progression. And this one is more interesting than the previous one. The previous one, I think, is the easier one. In GP, again, I told you how do you identify if it is AP or GP. You have only two types of progression over here, AP and the geometric one, right? So, and I told you how to identify if it is AP. You see that the consecutive terms, if they have a constant difference. So if your terms are 2, then 5, then 8, then 11, then 14, and so on and so forth, you find the difference between consecutive terms. You see it is plus 3, then again plus 3, then again plus 3, then again plus 3. So your D is constant over here. D is constant. So if your D is constant, then you would know that this is an AP. And if your D is not constant, for example, in this case, you can have other things as well. But right now, because we have only two things, so if it is not AP, then definitely it would be GB. For example, you have 2, 4, 8, 16, 32. So in this one, if you find the difference between the consecutive terms, plus 2, plus 4, plus 8, plus 16. So look, the difference, it is not constant. So definitely this would be the other one, which is GP. Now, if it is GP, now we know that it is a GP. So the GP has two things over here. The TN formula. First of all, the TN formula for GP, it is A R n minus 1. Where your A is again the first term. A is your first term. In this case, we have 2. A is your 2. Then your R. R is your called the common ratio. R is your common ratio. And the formula for R is simple. It is the ratio between the consecutive terms, two consecutive terms. So T1 upon T2, or sorry, T2 upon T1, or T3 upon T2, or T4 upon T3. So this is the ratio between the consecutive terms, two consecutive terms. And this would be common. So this would be the same for any two consecutive terms. The ratio would be same. For example, look over here in this case, 4 upon 2 is 2. 8 upon 4 is 2. 16 upon 8 is 2. 32 upon 16 is again 2. So this is telling us now that right now in this case, your R is equals to 4 upon 2, or it can be 8 upon 4, or it can be 32 upon 16. So it will be the same, which is right now coming out as 2. And your A is also 2. So the TN formula in this case, it is becoming, just replace them in the correct places. So 2 multiplied by 2 power n minus 1. And now using this thing, you can find any term. We know how the TN formula works because we did it in the AP. So now you can find any sequence, sorry, any term in the sequence. And they can also move from the position. For example, they can ask you to find the 100th term. Or they can give you the value of the term and then ask you to find the position of that term. So it works the same way as it was in GP. Oh, sorry, AP. But now the new formula is this A, R, n minus 1. And you have the R. R is your common ratio. And T1 over T2, T3 over T2, and T4 over T3. These are all, it would be the same. It is the ratio is common. So let's do some more examples. For example, you have 27, then you have, let's suppose, 9, then you have 3, then you have 1, then you have 1 upon 3, and so on and so forth. They're asking to find the TN formula. So you have the R, sorry, you have the A. A is simply the first term, 27. And then you have R. R is T2 over T1 or T3 over T2, which will be the same. So 9 divided by 27, which after simplification you get is R is 1 upon 3. So now the TN formula is A R n minus 1. So TN would now be 27 times 1 upon 3 power n minus 1. Okay, This is the simple.
n में क्या आएगा?
कहाँ आएगा?
आपने n लिखा है, n में आएगा क्या?
N is the position. If now they ask you to find the 50th term, let's say they ask you find T50. So now T50, the value of N is now 50. So 27 multiplied by not T50, it would be a very, let's suppose it's T7. So 27 multiplied by 1 upon 3 and 7 minus 1. So now your N value is 7. N is the position and Tn is the value at that position. The same like that we had in our AP. So now you calculate it. 27 multiplied by 1 upon 3 power 6, which is 1 upon 27. The value at the 7th position, the term is 1 upon 27. This is your answer. So there is a multiple, you can say, that you are multiplying every time and you get the next term. So in this one, you can see you are multiplying it by 1 upon 3. 1 upon 3, then multiplying by 1 upon 3, then multiplying by 1 upon 3, then multiplying 1 upon 3. So you get the next term by just multiplying the common ratio with the previous one. Okay. So the difference now you know. In AP, there is the common difference. You are adding that term, the previous term with a certain constant, and then you get the next term. Over here, there is a multiplier. You multiply the previous term with a certain constant, and then you get the next term. And now there are some interesting things about this around the values of R. Deeper. We are now going to go deeper, understanding the value of R. How your sequence changes according to the values of R. So now there are two types of two categories of values of R that we can divide our situation in. First of all, we have the region of R values which are between -1 and 1. Now this is a very important thing. Everyone, give me attention. So your R values, this is your R. So if your R values are between -1 and 1, and if your R values are more than 1 and less than -1. The green part, the red one and the yellow part. Now if the first case, if R is more than 1 and if R is less than -1, in both of these cases, the sequence is divergent. What does this mean? The sequence is divergent. This means that if you have a single value, starting value A, and the next term will be bigger than the previous one, then the next one will be bigger than the previous one, and the next one will be bigger than the previous one. So that's why I'm calling it divergent. It will open up. The values would become even more larger and larger and larger and larger. So this is called a divergent sequence. When the values are infinitely getting larger, there is no end. For example, if I had the first example over here, what do we have? What did we have? We have 2 multiplied by 2 power. It was n minus 1. So x minus 1. So if your value of x is look 10, so 1024. If your x value is 20, or let's suppose 20, yes. So even larger number. Then if your x value is 50, even larger number. Then 100, more larger. So this means that the values will keep on increasing. The magnitude of the sequence will keep on increasing. When in both of these cases, when your R is greater than 1, because you multiply a number which is bigger than 1 with the previous one, so that definitely you will get the even bigger answer. So the next term would be even bigger than the previous, then again and again and again and again. So this would diverge. The sequence will not converge, it is diverging. Same is the case when your R value is less than 1, less than -1. For example, if you have, I will tell you the difference what happens when you have a negative R. Let's suppose you have a -2. R is your -2. Look at the formula A, R, N minus 1. So R is your -2. So in the same, in this case as well, the value would again keep on increasing. 20, you have a base smaller value, then 30, even bigger, 40, even bigger, 50. Again, it would keep on increasing with both of these R. If your R value is in the yellow region, so the conversion, your sequence will be divergent. Now, if your R value is between -1 and 1, then your sequence is convergent. What will happen in this case? The next time would become even more smaller. It would converge like this. So if your A would be the first term would be the largest one, and then the values would become smaller and smaller and smaller, up until it would get so small that you can call it a 0. It can never be 0. It will not never be 0, but it will be such a small number that eventually you can say that it will, after infinite number of times, it will reach 0. For example, in this case, 1/3 power n minus 1. So your x, look, x, if let's suppose it is your 10 or 5. So you have answer is 1/3. When your x is 5, when your x is 6, look, getting smaller, 0.1111. If your x is 15, 15th term, even a smaller number. If your x is 20, even a smaller number. Then if 100, look, -10 power -46. So now the values are getting smaller and smaller. So as you are going further in the sequence, your values are getting smaller and smaller and smaller and smaller. If, look, over here I take a very, very large value, it will give an answer of 0. Because it is not 0, but it is such a small number that my calculator is giving me an answer of 0. It will never be 0, right? This is a sequence. It will keep on forward moving. But the values are now coming to a stop. They are coming together at a single point, you can say, converging. The sequence is closing. So this depends on the value of R. And one more thing, if your R is negative, if R is negative, less than 0, then your sequence have alternate signs. Sequence terms have alternating signs. For example, the first one is positive term, the second one will be negative, then the third one would be positive, then negative, then positive, then negative, then positive, like this. For example, we took the example. Let's take another example. 3 multiplied by the R value. I'm taking R as, let's suppose, 3, and power x minus 1. I'm taking the R of -3, right? I wanted to try to show if your R is negative, what happens. So look, the first term will be 3. The second term is -9. Look, +3, then -9. Then the third term would be +27. Then the fourth term would be -81. So it would work like this: 3 minus 9, then +37, then -81, then +243, then -7 something, I don't know. This is the sixth. 729. So plus minus, plus minus, plus minus. Why? Because you are multiplying it with a negative multiple. So negative negative becomes positive. Then positive negative becomes negative. Then again negative negative becomes positive. Okay. These are the simple, you can say, what the effects of the values of R on the sequence. On the fourth term, you will see that if your R is equals to 1, or if your R is equals to 1, so your sequence will not change. Sequence will be the first term, because you're multiplying the next number with 1, then again 1, then again 1, then again 1. So you will get the same term out of it. So there will be no change across the terms. For example, you have 27, then you're multiplying the 27 with 1. You will get again 27. Then you're multiplying 27 with 1, again 27, again 27, again 27. So your sequence won't change if your R is 1. And lastly, if your R is -1. So what will happen? The sign of the terms will change, but the value, the magnitude won't change. For example, it is 3. So it will remain 3, 3, 3, 3. And but in over here, it is, let's suppose 3, then the next one will be -3. Then it will be 3, then -3. Then it will be 3, then -3. So the signs will change because of the negative R, but the magnitude won't change. You won't see these. I'm just giving you as an explanation, as a deeper understanding of the how R will affect your sequence, but you will never see that this is the case. But I'm just telling you, if your value of R is 1, then this is what will happen. If your value of R is -1, then this is what will happen to the sequence. The most important parts are these two. Depending on the value of R, if your R is between -1 and 1, then your values will converge, will get closer and closer to 0, get smaller and more smaller. And if your value is from the yellow part, the R value from the yellow part, then the sequence will keep on increasing in size. Okay, copy this down. All of these formulas, these understanding. If you have any questions, ask. And now we'll move on to the sum of the sequence, sum of the first n number of times. Okay. Okay, now we move on further. Now, what about the sum formula? So, according to the value of R, if your R is between -1 and 1, so now the sum formula, the sum of the first n number of times, it is like this: a 1 minus r power n. N is the number of terms upon 1 minus r. And if your r value, if it is more than 1 and if r is less than -1, then the sum formula is a r n minus 1 upon, look at the difference. It's just the placement of r is different. Otherwise, the same formula. On the left one, 1 is coming before the r power n. On the right one, r power n is before -1. Now this is for the sum of the first n number of terms. Okay, now let's do some questions. So they've given you the first, we are doing part B, not this. The first term of a progression is 16. So A is 16. First term is 16. Second term is 24. So T2 is 24. T1 is 16. They're asking you find the sum of the first 8 terms. Sum of 8. If the progression is GP, if the progression is geometric. So geometric is, you will use the sum formula, these two formulas, either one of them. So we have the value of A, we will need the value of R. So R is T2 upon T1, the ratio between the consecutive two terms. So T2 is 24 upon 16, which is equals to 3 upon 2. So you can see the value of R is more than 1. 3 upon 2 is 1.5. So this means you will use this formula. So the sum of first 8 would be, look here, A is 16. Then R power, how many is the number of terms? 8. And R is your 3 upon 2, which is 1.5. So 1.5 minus power 8 minus 1 upon 1.5 minus 1. And so now use your calculator. That's it. So 788.125. This is the answer. This is the sum of the first 8 terms. That's it. You found the value of A, you found the value of R, and you had the formula, you replaced the planes in their places, and you got the answer. That's it. Allah. Sum to infinity. Okay, look at this question number 45. You have some questions like these. Then I'll move on to, after this question, I'll let you know what is sum to infinity. The first part, you have a lot of questions in past papers like that. So they have given you three terms in the GP. So term 1, term 2, term 3. So term 1 is k plus 12, and the second term is k, and the third term is k minus 9. And they've given you, they're asking you to directly find the value of k. So this is GP. Now we know when it is GP, then the R is constant. We have the common ratio, which is equals to T2 upon T1, and which is also equal to T3 upon T2. So if you replace the things over here, so T2 upon T1 is equals to T3 upon T2. And now you have formed the equation. Cross multiply, you'll make the equation. So k square is equal to k minus 9 into k plus 12. And so now I expand this. So k square minus 9k plus 12k and minus this would be 108. So now k square cancel out. 3k minus 108. So k will come out as 108 divided by 3. $36. That's it. So now the three terms are, the first is 36 plus 12 is 48. The second is 36. And the third is 36 minus 9, which is 27. You have done the first part. Any questions on the first part? Anyone?
नहीं सर.
Okay. Now the sum to infinity. Now this is interesting. Sum to infinity, the formula for sum to infinity is a upon 1 minus r. You have to learn this formula. This is called sum to infinity. And this only works when your value of r is between -1 and 1. Why? Because the sum to infinity, otherwise it is not possible. It would be infinity. For example, I told you, so according to the value of r, over here, look at this. Sum of the first n number of terms. This will tell me that I would have to add. So t1 plus t2 plus t3 plus t4 plus infinity, let's suppose bigger number. So even if the next number is larger than the previous one, so there would be no specific. It is not converging, it is diverging. So your the sum to infinite number of terms would also be infinity, because you are just adding a bigger number to the previous number, which is bigger than the previous number. So when your value of r is this one, when your sequence is divergent, your sum to infinity will be infinity, because the next term will be bigger than the previous one. So they would just add up, and the sum would keep on increasing. Okay, so in this case, the sum to infinity is infinity, and infinity is not a number. It is infinitely large value, which can increase as bigger than what you can think. But over in this case, when your sequence is convergent, then your sum to infinity is possible. Why? Because the next value is smaller than the previous one. The next value again is smaller than the previous one. Smaller. So it gets so small, the value, that eventually a very further at the end of the term, at the end of the sequence, it is almost zero. So value is so small that it is almost zero. So in this case, if you add up all of the terms to the previous ones, they can converge. The sum can also converge, because the values of the sequence are converging towards zero. So the sum of the sequences, they also converge to a single value, which is A upon 1 minus R. Because they're getting smaller and smaller and smaller. Do you get it? समझ आया? Any questions? Sanchi, Rayan, Munib, Mohit, Abhiyan.
Sir, I guess so much.
It's logical if you think about it more also. If your values are getting bigger, so the sum of those previous all values would also be bigger than all previous values. So sum to infinity over in this case is infinity. It is a very, very large number. It will the next time if you add the next term, it will be even larger. But over here, your values are converging towards a value which is 0. So the sum is also possible because you are adding up values which are getting smaller and smaller and smaller. So the sum would also stop at one place because the terms are stopping. That's why. So now what happens? This is the logic. And over here they're asking you now to find the sum to infinity. So what do we have? We have the value of A. A is 48. And the value of R. R is 36 upon 48. Right? T2 minus T2 upon T1. Which will be 3 upon 4. So now your sum to infinity will be 48 upon 1 minus 3 upon 4. So 48 upon 1 minus 3 upon 4. 192. 192. That's it. This is your sum to infinity in this case. And I can show you this sum to infinity using this formula as well. But this one. If I take the same situation, look. The first term was 48, then we have 1 minus R was 3 upon 4, right? 0.75. Power n. N is your term, right? The number of terms that you want the sum of. 1 minus 0.75. So look, if it is the first term, the sum is simply definitely 48. Then you have, let's suppose, let me change the variable. Let me put a variable over here. If your x is, look, 1, then your sum is 48. Then if your x is 2, then you're adding up, look, 48 plus 36, it is 84. Then plus if you have 3 terms, if you take the first 3 terms, then it is 1 for 1, 1, 1. 48 plus 36 plus 27. If you take the first 4, it's just adding up the next term as well. If I take, look, 10 terms, 181.2, something like that. If I add the 50 terms, so look, it's getting 191.999. It will get closer and closer to 192, but it will never give you the answer to 192. 70. 191.9999. 6 nines now. If it is 80, now there are 7 nines. It's getting closer and closer to 192. But if I take a very, very large number, let's suppose 500, it is giving me 192. Because the 500th term, it is so small that it has eventually converged. The sum has also converged. It is never 192. But the actual value over here in this case also, it will not be 92. But because of the limitation of the calculator, it has rounded it off and it has given you 192. And if you take definitely now infinite number of terms, the answer would be 192. The answer won't be, the sum of the terms won't be increasing more than 192. Okay. Any questions, anyone?
Nice.
No.
Sir.
Copy this down. This is a good example. Now you have just these 4 formulas, or I think 5 formulas. The Tn formula for the AP, the sum formula for the AP. Then you have the Tn formula for GP, and the sum formula for the GPs, the 3 sum formulas, the sum to infinity, and the sum formula according to the values of R. Everything will be revolving around these things. So for AP, the most important part is finding the A and the common difference. The first term and the common difference. Everything you would be able to do it if you get the A and the common difference for the AP. And over here, you would be able to get everything if you have the A, the first term, and the value of R, which is the common ratio. So have this in your mind. This is your objective. Find the A or R if you have GP. Find the A and D if you have AP. Otherwise, they will just try to complicate things according to the information. They would either give you a application-based question, but it is not a difficult topic. Everything revolves around those 3-4 formulas that I told you. They can look. Let's put a little bit of trigonometry over here. Question number 5, but we won't do that right now. Okay, look at this one. Question number 5. 5 marks. Sorry, question number 6. Now you can try any question from here. They were just a little bit complexity in the information that they've given you or in the algebra part, but there would be nothing new logic that you would need. Everything would be revolving around the logic that I've given you. So they have given you, look, the second term of GP. So this is GP first of all, and the second term is 54, and the sum to infinity is given to us. It is 243. So A upon 1 minus R, it is equal to 243. And one more thing that you may need, just like we did the generalization over here in AP, this generalization, that your T74 is A plus 73D. T210 is, the coefficient of D is just 1 less than the prime number. Over here as well, we can do some generalization. T1, T2, T3, T4, T5. Similarly, if you have T60 or T200 or T700, anything. So look how your formula changes. T1 is the first term to A. T2 is A R 2 minus 1, which is A R power 1. Then A R 3 minus 1, which would be A R square. A R 4 minus 1, which would be A R cube. So look, the power of R is 1 less than the term number. So A R, this would be A R power 4, because it is term 5. So power is 4. If it is term 60, then the power would be 1 less, AR 59. If your term is 200, then your power will be 199. If your term is 700, then your power will be 699. That's it. Generalization. Okay, now we apply this. So if it is the second term, look, second term means that your A power is 1. Sorry, R power is 1. So AR1 is equals to 54. So you have to now solve them simultaneously. You have this formula, sorry, this equation, and you have this equation, and then you will solve them simultaneously. So how would we do this? R is equals to 54 upon A. So A upon 1 minus R. R is 54 upon A is equals to 243. Do the cross multiplication, or if you take the LCM, A upon A minus 54 upon A. So this A would go over there and multiply. So this would become A square is equals to 243 upon A minus 54. A minus 54 would go over there and multiply. So 243A minus 54 times 243. 13122. Now move everything on one side. So A square minus 243A plus 13122 is equals to 0. Solve them. 1 minus 243, 13122. So your A is 81 or your A is 162. A is 81 and A is 162. Now you find the value of R. R is 54 upon A. R is 54 upon A. R is 54 upon A. Now they have given you that the common ratio is greater than half. So I think greater than half would be 54 upon 81. 54 upon 81 is 0.6666, 2 upon 3. And this is 162, 0.33, 1 upon 3. So this is the answer for the value of R and for the value of A. You would cancel this one. Find 10th term, giving your exact answer in exact form. So now the 10th term, generalization. 10th term would be A R power 9. Power is 1 less than the term number. So 10th term is A is your 54. R is 2 upon 3. Power 9. And they have asked us to give it in the exact form. Let's see. 54 multiplied by 2 upon 3 power 9. 1204. Oh, sorry, 1024 upon 729. This is your answer. Okay. Easy 5 marks. Any questions? Easy topic. I think it is easy. Let's see. Now the topic is complete. You people have to do the past papers. I'll share you the past papers of this one as well. We are done with a lot of topics now. So now start preparing for the test. We are done with functions. We are done with quadratics. We are done with expansion, binomial expansion. So many topics done for us. So start preparing. Quadratics as well done.